Hi, my name is Robert Kane, and welcome to the Fundamentals of PowerShell Programming. In this video, we'll cover the fundamentals of PowerShell programming. If you're a developer, many of these concepts will be familiar to you, and it will be easy to pick up the syntax. If not, don't worry, the concepts are quite easy to learn. We'll begin by looking at branching, executing code based on a set of conditions. Then we'll look at looping, which will allow us to repeat a block of code. Speaking of blocks, we'll look at what a script block is and how to use them. Finally, we'll build on what we know about variables when we talk about variable scope. Most languages support the concept of branching. Branching is simply making an evaluation of some expression and then having certain blocks of code run depending upon the output of that condition. Here, I'm assigning the value of 2 to a variable, and then I'm using one of the simplest branching constructs out there, an if-else. The if statement will evaluate what is in the parenthesis. In this case, does $var equal 1? Within the parenthesis, I can put just about anything, as long as the final result of this expression is either true or false. So, $var equals 1 in this case is going to be false, so it's going to fall down to the code inside the else. Otherwise, if it had been true, it would have run the code here in the if statement. So let's go run this. And as you can see, it prints out else branch. Many languages also have a construct called if-else-if, which is just a way of having extra else conditions in here. PowerShell does not have that, so what you have to do is nest another if block down here in the else clause. So here, we're going to come here and run this. And now you see we're on the if equals 2 branch. So this failed, became a false, so it branched down here to the else. And now it's going to do another evaluation, and this time if equaled 2, so it said, hey, we're good to go, and we're going to execute the code inside here. Anytime you see code with squiggly braces around it, that's known as a script block. We saw how if statements are good for either if or else, one outcome or the other. But what if you have multiple things that you want to check for? Well, for those, you'd want to use a switch statement. Here, I'm going to assign the value of 42 to my variable, and then I'm going to switch based on it. Well, in the switch, it'll first check for the value 41, then it's going to check for the value 42, and if it matches, it's going to execute what's in the script block. Otherwise, it's going to check for 43, check for default, and then exit. So let's go run this. And you can see it prints out 42. If I come up here, and we'll change this to say 43, and rerun it, I get the value of 43 out. And if I change it to some value that's not in there, say 49, and run it, it'll hit the default branch and say default. Now, when I said it will check for 41, then it will check for 42, then it will check for 43, I was being quite literal. Just because it found a match on 42 doesn't mean it stops checking. Here's a little example. Let's clear the screen. And we're going to assign the value 42 again. And then we're going to come in here to the switch statement. Now when I run this, you'll see I actually get both 42 and 42 string out of here. What's happened is PowerShell first compared the integer value of 42 to my integer variable, which also happened to have 42 in it, and it executed that script task. And then it came down here and said, okay, I now want to compare this. Well, this is a string 42, so PowerShell then converts that to an integer, so it's comparing an integer value to the integer value in my variable. And thus it found a match, and I got the string out. And of course, since it did find matches above, it did not execute the default code. Sometimes that can be pretty useful. You want to be able to check for multiple conditions and have the same code execute for various reasons. But what if you don't want that? How do we stop that? Well, we can come down here and we can use something called a break. Again, we'll clear the host and we're going to assign value 42. And this time, at the end of this first 42, I'm using a break command. So I have a semicolon and then a break. If you're in a script task and you want to have multiple commands, which are normally on individual lines, all bunched up on the same line, you use a semicolon to separate them. So here, we're going to switch in here, and now we're only going to get the string 42 and not the second one of 42 string. That's because it hit the break statement and exited out. Switch also works with collections. It will loop over the collection and execute the code for each item. So here we've got 4 items, a 3, a 1, a 2, and a 42, all separated by commas. Now, I'm making this simple. This could also be an array you're passing in or a collection of objects. So here I'm going to execute this code. And there we go. I actually get 3 because the first time through it found a match. Then the second time through it found a match for 1. Third time through it found a match for 2. And on the last item, 42, it didn't find a match at all. It's important to note that comparisons are case insensitive by default. What this means is the case of the strings are ignored. Here I'm going to compare a capital P Pluralsight, and I'm going to compare it to Pluralsight all in lowercase, all in uppercase, and in mixed case. And when I run this, I actually find matches for all 3. If I don't want that, if I want my comparison to be case sensitive, I simply have to pass in a dash case sensitive switch. So now it will only find 1 match for mixed case. The switch statement also supports wildcards. Here I'm going to switch, and this time I'm going to indicate that it's a wildcard search. So now it's going to look for plural asterisk, and if the value I'm passing in matches that wildcard, I'll get a result back. It also supports single question mark or multiple question marks as character placeholders. So now when I run this, I'll actually get matches for all 3 of them. And sure enough, I get my asterisk, my question mark, and my triple question mark back. Note too that the switch statement also supports regular expression matching. Looping is another fundamental construct of most programming languages. PowerShell supports a wide variety of looping features. The most basic is the while loop. Here, I have a while command, and then I have a little script block below it. While the condition within the parenthesis is true, it will execute the code within that little script block. So here I'm going to set a variable to 1, and then I'm going to loop through my while loop, and each time I'm going to increment the value of I by 1. So let's run this. And there we go, it simply listed those values, 1, 2, 3, 4, 5. Interesting thing to note that the while loop won't execute if the condition is already true. So here I have set the value of I equals to 6. Well, in the while loop, I less than or equal to 5, well, obviously 6 is greater, so there's no reason for this to execute. So I'm going to run this just to show you. And nothing happened. Now, if I want to make sure that the loop executes at least once, regardless of the value of the initializer, then I can come down here and use a do while loop. In a do while loop, I also have to set my variable, I equals 1 in this case. I have the word do, and then I have my script block. And you'll notice down here, my check is at the very end of the loop, while I is less than or equal to 5. So let's come here, and we'll run this. You can see, sure enough, I print out 1, 2, 3, 4, 5. Also note, in this case, I've used the unary operator, $i++. It's the same thing as $i equals $i+1, just a little bit more compact syntax. I mentioned that the while loop's always going to execute at least once when it's used in this do while structure. So here I've set the value of I equal to 6. When I execute this, unlike the plain while loop, it executed at least once because it didn't do the check until the very end. Something else I'd like to point out about the while loop. If we look at our condition, we're looping while a certain condition is true. So as long as $i is less than or equal to 5, it's going to execute the loop. Once that condition becomes false, it stops executing the loop. Now some people kind of like to have the reverse logic. They want to execute until a condition is true. Well, to handle that and to make our checking a little more positive, instead of a do while, we can use a do until. So here you can see I've set I equal to 1, and I'm going to do until I is greater than 5. So let's highlight this so we can run it. And there we go, 1, 2, 3, 4, 5. So as long as our condition was false, I was less than 5, then it executed the loop. Once that condition was true, that's when the loop stopped executing. Now, the do while, do until, and while are great for iterating while you're looking for a certain condition. But what if you just want to loop over a set number of times? Well, for that we have a for loop. Here on the for loop, we're going to execute this script block right there while these conditions here within the for are set. Now this first item you see is the initializer. In the initializer, you take a variable and you set it equal to some value you want to start counting from. So in this case, we're going to start counting from 0. The next thing is our condition that we want to stop on. So in this case, we're going to execute while f is less than or equal to 5. Then after the ending semicolon, we've got our incrementer. In the incrementer, it tells us how many to increment our variable by each time through the for loop. So here, we're going to increment this by 1 because I'm using $f++, and that's kind of the traditional way to do things. However, you made it increment by 10, 20, 100, whatever works for you. So we could have easily said $f plus 100. So any of these would have worked. So we're going to come here and we're just going to execute this. And there we go, 0, 1, 2, 3, 4, 5. Now, notice that we can set the initializer separately. So here I've set f to 2. When I want to set the initializer outside the loop, I simply leave the initializer section of my for block empty. So here when I run this, you can see I get 2, because that's what it started with, 3, 4, 5. I can also use a for to loop over a collection. If you recall from our discussion on variables, we can address individual items within an array or in a collection by using a left bracket and then a variable that points to the position inside the array. So here my array is $array, and then $i is going to represent the pointer into the array for the item I want. So here I've set up a simple array, and I'm going to hold the values of 11, 12, 13, 14, and 15. In my for loop, I'm going to start counting with 0, and then I'm going to go while $i is less than the length of the array, and I'm going to increment by 1 each time through. Now, in case you're wondering why I'm not going to less than or equal to, well, let me show you. Here, let's load up the value of the array. Let's actually go find out how many items are in the array. And sure enough, we have 5 items. But the pointers actually start at 0. So even though I have 5 items, they're addressed as 0, 1, 2, 3, 4. As you can see when I run this, there we go. 0 holds the value of 11, 1, 12, and so forth. Here I'm using the for loop to explicitly address an individual element within my array, and I'm having to do so using a positional notation. But what if I don't have a traditional array? Maybe I've got a collection of objects. Well, for each works on collections. So here, I'm going to use an array again, but an array, you have to remember, is a collection. So I'm going to load up the array, and then I have my for each construct. Underneath it, you can see the script block is simply going to print out that items equal to $item. Here we have $item in $array. Well, $array is the collection I'm going to work with. So $item is a variable that's going to hold the current value as it works through each item in the array. I've called it $item, nothing magical about that. I could have called it $Fred if I wanted to. So let's run this. And you can see from the output, the first time through the loop, the for each took the value of 11, which was the first item, and plugged it into the $sign item. Then the next time through, it put the value of 12 into $sign item, and so forth. The cool thing about for each is because it works on an array of objects, it can also work on the output from various commandlets. So here, I'm going to do a clear host, and I'm going to set my current location to my samples folder, and then I'm going to do a for each, and I've named the variable $sign file, and I'm going to use the get child item commandlet, which is going to return an array of child items, and I'm going to loop through each one of those and print out the name. So here, when I run this, you can see I get all of the files in that particular folder. If I want to make this a bit spiffier, maybe I want to focus down and get just the PS1 items. Well, that's where I can really start building upon what we've learned so far. Here, I'm going to use an if statement within the for each. I'm going to use the -like comparison and compare it against the wildcard of star.ps1, or some people call it an asterisk.ps1. And if the name ends in ps1, only then will I actually print it out. So now when I run this, and we'll contrast it to what we have down below now, and my new output only has my PS1 files. Now, what if I'm in a loop and I want to get out of that loop? Well, for that, I can use the break command. You may recognize the break command from the switch statement, and it works somewhat similar in that it exits the current loop. So here, I'm going to have the same command I had before, but after it prints out that first file name, it's going to use the break. So let's come down here and run this. And now you can see I only get one file name printed out. That's because once it hit that first if statement and said, oh, this is indeed a PS1 file, the break command exits the for each and begins executing code at the very next line. It'll be to this line right here where I'm putting out the Fs. What if I don't want to break? What if I actually want to do is skip over the rest of the loop but go back and to the next item in the loop? Here, I've got similar to what I've had before, but instead of using the word break, I'm using continue. What's going to happen is when PowerShell hits this continue, instead of executing any more code left in the for each loop, such as this isn't a PowerShell file, it's instead going to move control back up here to the top of the for each loop and then keep looping. When I run this, you'll see what I mean. Highlight that. And there we go. For the PS1 files, the code, this isn't a PowerShell file, never executed, and it only printed out the getChildName.ps1, module1.ps1, and so forth. For those items that were not PS1s, it skipped over the if statement and instead printed this out. What happens if I'm using breaks or continues inside of a nested loop? We haven't really talked much about nested loops, but it's possible to have one loop occur inside of another loop. Here I'm using a break inside the inner loop, and what's going to happen is, with a break, it's going to return control back to the start of the parent loop. What actually happens is, it hits the break, it's going to come down here to the next line, which is the squiggly brace that says, oh, go back up here, and it's going to execute this again. So let's run this, and I think it'll make it a little clearer what happens. Now here you can see the outer loop we've executed 1, 2, 3, but the inner loop we only executed once, beginning with 4, because we hit the break statement each time. Also notice this little piece of clever coding down here. If we get to it, where I have 1.3, and down here I have 4.6. If you recall from an earlier video, I can use a range notation such as 4.6, and what that does is it returns a collection or a range of values. So in this case, it simply evaluates 4.6 and says, oh, you must want a collection of numbers in the range 4 through 6. So that's why we were able to work this inside the for each loop, which required a collection. Now let's go down here, because what I want to show you here is that you can use labels to break to a certain point in the loop. Here you can see I'm using a break command, but after the break I've put the outside loop label. Up here I'm using a colon to indicate that this is a label designator. So let's run this and you can see what's going to happen. Okay, in this case we broke, but unlike before when we were able to execute the all 1, 2, and 3 from the outside loop, because it broke, we said we'll break to the outside loop, and it said, oh, in this case I want to now break out of this loop and come down here to the line afterwards. Likewise, I can use continue with my inner loops. And continue will work somewhat similar to the break, except it doesn't return control back to the parent. It just goes to the top of the current loop. So now, when I run this, you can see I actually get outside 1, 4, 5, 6, 2, 4, 5, 6, and 3, 4, 5, 6. Because the only thing that continue did was skipped over the line that says this will never execute, which is this line right there. I can also use labels with continue. Here you can see I've used outside loop again. And now the behavior winds up being a little closer to what you saw with the break. Okay, here it only runs the 4 because it continued back to the parent loop. And notice when it continued back to the parent loop, this line down here that was after the for each will never execute, because at this point I'm jumping control all the way back up to here. So you've had a chance now to look over the various kinds of looping we have inside of PowerShell. I want to caution you to be real careful using the break and continue keywords. Break and continue can be the cause of many logic errors within your applications. So use them sparingly and always see if you can find an alternate way of doing things before you wind up resorting to break and continue. In our previous discussion on looping, I mentioned that what a loop actually executes is a script block. A script block is defined by curly braces. So here, within the curly braces is a script block. It's time now to look at script blocks and how you can use them within your own PowerShell programming. Here I have a simple script block with two commands, clear host and to print out the static text PowerShell and bow ties are cool. It's a script block because it's defined within curly braces. Also note that because I have multiple commands on the same line, I had to separate them with a semicolon. If, however, I were to highlight this and try to run it, nothing really happens. It doesn't clear the host, and it doesn't really print out my command. That's because when I execute it, it only shows the contents of the block. It doesn't actually run the code inside it. Another thing I can do with script blocks is assign them to variables. Here I'm going to take that same script block and assign it to the variable, $cool. Again, all it does is assign it. It's not actually executing anything. If I were to just simply run $cool, again, it just prints out what's in there, which in this case is the contents of the script block. It doesn't actually do anything. So I'm sure by this point you're probably yelling at your monitor, yeah, but how do I actually execute it? Well, to do that, you actually use an ampersand in front of the variable. So here I have ampersand $cool, and now it has actually cleared the screen and then executed the command to print out PowerShell and bow ties are cool. It also works on an actual script block. It doesn't actually have to be inside of a variable. Here I'm clearing the host and then followed by a command to print out some text, and when I run this, we can see it's cleared the screen and printed out our Fez hats are pretty cool too. Now, because scripts can be put in variables, we can do some interesting things. Here I'm doing a couple of things. First, I'm assigning a simple script block that will print out some text. And then I'm copying the contents of cool wall into my sub-zero wall. Now, in essence, that actually copied over everything in that script block into my second variable. So now I'm going to enter a loop. I'm going to execute the loop 3 times, and each time I'm going to execute the code inside my variables. Now this will actually have the effect of printing out my text 6 times, which is what you can see what happened. Now, if I want to return a value from a script, I have to output it in a way that nothing else consumes that variable before the script ends. Here, I have a very simple script task that adds the value of 1 to 41. So I'm going to assign it to the value, and then I'm going to execute it, and it prints me out 42. Now, I can actually have this script block execute and return its value so I can do something else with it. To do so, I have to enclose it within parentheses. So here you can see I have 1 plus, and then inside parentheses, my ampersand to actually execute a script block, and then the script block itself, which is contained in $value. And you can see here, it returns 43. And remember, if I don't put it in parentheses, I get a big red error message within my PowerShell environment. Now, here I have multiple commands within my script block. And remember a second ago I said it returns the first value that is not consumed. So what's going to happen is it's going to first hit 42, and then it's going to write out the host. Because 42 is not consumed, it's going to return that to the screen. So here, I actually return 42 because it's not consumed, and then I execute my write host command. Now, down here, I'm actually going to do something with that 42. I'm going to add it to the number 1. So now what's going to happen, it's going to return the value of 42. It's going to execute my write host command to print PowerShell is cool to the screen. And then it's going to take that value I returned of 42, and it's going to take it into the rest of my equation, add 1 to it, and give me the result 43. This next example may make it a little clearer. Here I'm going to take the output of my script task inside value, and I'm going to place it in the variable 42. So when I run this, you can see it does display Pluralsight is cool, and it took that first value that was not consumed, 42, and placed it into my $42 variable, and I can actually prove that by printing it out. There's another command that works well with script tasks, and that is the return command. Here I can actually return a value. Note though that when I use the return command, it actually stops this rest of the script block from executing and returns control to the calling area. So here, when I execute this, you can see it returns 42, but it never does the write host command. That's because the return command said, stop running the code, return whatever I've got here, and get out. Down here, if I use return by itself, no value is returned because it stops the script executing. And boom, it doesn't print out anything. It is possible to pass parameters into our script blocks. There's actually 2 methods to this. In the first method, we use something called the arguments collection, or args. This may be familiar to you if you've done some C programming before, but if not, it's pretty simple. All of the arguments that you pass into your script block are placed into an array. So here, I'm assigning what is in the first position of my arguments array to the question, and I'm assigning what's in the second place, position 1, to the answer. I then take that and write it out to the screen. So here, I'm going to assign QA, and now my script block is assigned, and now I'm going to execute it, and I have 2 items passed in, and it correctly returns the formatted text. Note too that since my parameter has spaces in it, I had to enclose those parameters within double quote marks. You would need to do this kind of thing for, say, text, or if you're passing a path to a file into a parameter and that particular path had spaces in it. There's a second way we can pass parameters. It is a slightly more readable method where we use the param command. Here I've told my PowerShell script, okay, I'm defining a couple parameters. The first one's called question, the second one's called answer. Now, when I take all this script and execute it, you can see I get pretty much the same results as before. So you may ask yourself, well, what's the difference and why should I use one over the other? Well, the second method, the parameters are a lot more clear. They're also named, so we can use those to our advantage in a moment. The main reason you would want to use the first method is because you can have a variable number of arguments each time. You can query the count property of the $args variable to find out exactly how many parameters are being passed in, and then execute the code within your script block for each one of those items, say in a for loop, for example. So to sum it up, in cases where you need a variable number of arguments to a script block, use the $args. For the rest of the time, I would encourage you to use the param command. Now, not only does it make it clear because we actually have explicit named items, but there are some more things we can do with it. For example, I can actually pass my parameters by name. Here you can see I place a dash and then the name of the parameter. This is the same thing we defined in the variable params, except without the $sign. So here we have question, what else is cool, and we have the answer. And you can see that code executed. Now the nice thing about name parameter is I don't have to get the order correct. Here I'm going to put the answer first, then the question. Another nifty thing is I don't have to give it the full name of the parameter. I can only pass in enough of the parameter name to make it clear which one I'm talking about. Here my two parameters start with completely different letters, so I can just put -a and -q. And there we go, that worked just fine. Now what happens when a value is not passed? Well, if I pass in question and not the answer, you can see it just essentially acts like I passed nothing or a null into this. Now, I can also check to see if a value is missing. So here within my script block, I can actually use the exclamation mark, what some people refer to as a bang symbol, and I can say if not answer, then I supply the value for $answer of error, you must give an answer. So when I execute this, and we'll actually run the command, and now it's actually detected that I passed nothing in for my answer, and it's giving me an error message. If I wanted to be able to handle this but not have an error of some kind, I could actually supply a default value for my answer. To do that, within the syntax of the param command, I simply have an equal sign after the name of the parameter, and then I place the default value. So here I have $answer equals, the question has no answer. When I run this, it's now substituted my default value for answer. It is possible on our parameters to use explicit typing. Here I want to force my two variables, x and y, to be integers. So I'm going to run this, and you can see when I actually run my math variable and I pass in the values of 3 and 11, I get the value 33. Now down here I'm going to try passing in a 3 and then a string of x. And now we'll see that we have a big error because x is not actually an integer, it's a string. It's possible to make script tasks that you can put in line with our pipelines. This is going to make them extremely powerful and versatile because pipelines are one of the fundamental foundations of PowerShell. So here I'm going to set the location to my samples directory. And then I have a script task called only cool files. To pipeline enable it, I need to use a process keyword, and then I have another script block after process that says what I'm supposed to do. This is very simple, is I'm going to look for the name property of whatever's coming in, and I'm going to see if it's like *.ps1, and if so, I'm going to return its name. You'll notice I'm using a $bar and then an underscore. This is a special variable name that PowerShell has for the current object. It's not unlike when we used a for each block and we had to supply a default name for the current object. Same thing, except this is one that PowerShell has built in for you. So let's assign this. And now let's come here and we're going to clear the host. And then we're going to use the getChildItem commandlet, and we're going to pass its output through the pipeline into our script block. And there we go, we're displaying only our PS1 files. There are times when I want to have code that executes before or after the pipelining processing code. To do that, we have a couple of more commands we can use. There's a begin command and an end command. The begin, of course, will take whatever is in that begin script block, run it first. Then, for each item in the pipeline, it's going to do the process. And then, at the very end of it, it will execute whatever is in the end script area. So let's assign this to what's in my only cool files variable. Run it. And now, I'm going to run that code. And here you can see it's printed out some text of, here are some cool files, which you can see right here. It's printed that out at the beginning, then it's executed all of the code, and at the very end it returns all of that in one big block. Now let's say I wanted to have that message be something of a variable. Well, I can combine some of our earlier techniques, and I can combine pipelining with parameters. Here I've declared a parameter called header text. And now in my begin block, I'm actually using header text instead of my static string. So now I'm going to load this into my variable. And we'll come down here. We'll clear the host. And you can see in this first example, I'm passing in my here is my cool header text. But in my second example, I'm passing in a different header text. And there we go. Pretty cool stuff. Now that we've had a chance to look at script blocks, it's time to fall back again with variables and talk about variable scope. Variable scope simply means how do variables react with each other both inside and outside of a script block. The first thing to know is any variable declared outside of a script block is available inside of a script block. So here I'm assigning the value of 42 to my $var variable. As you can see, that variable is the same when I access it inside the script block as outside. But what if I try to change the variable inside of the script block? What would happen then? Well, if I try to change it, PowerShell will make a copy of that variable, and it will then work with that copy for the rest of my script block. So here, within my script block, I've assigned the value 33 to my variable. So now when I run this, you'll see that inside the script block, it now has the new value of 33. But when I come back outside the script block, it still has the original value of 42. Now this may seem a little odd at first, but it actually has great benefits. Oftentimes the people who write script blocks are not the same people that actually use those script blocks. So what this means is you, as the writer of a script block, can use variables and not worry about what variables the people who are going to consume your script block have created. In this case, if both of you had used the same $var, then you might be in trouble if PowerShell used something other than the behavior you've just seen. So now that you've seen it is safe to use any variable name you want, what then if you actually want to interact with variables outside of your script blocks? Well, if you recall from an earlier discussion, we mentioned the getVariable commandlet. And that getVariable was simply a substitute for displaying that, what the value of a variable is, and if it's pretty much the same as displaying only the value. So here, if I were to just put $var on the screen, it would be the equivalent of calling getVariable var value only. And there we go, we get 42. Now setVariable, as you recall, is a shortcut for saying $var equals. So here you can see when I assign the value 99, it's the same as saying $var equals 99, and we'll prove that by using the getVariable on that. Let me clear the display. Now the cool thing about get and set variable is they support scope as a parameter. The default 0 is the current scope, with 1 being the parent, 2 the grandparent, and so on. Using scope, we're going to be able to see both the local copy and the parent copy of the variable. So here I have $var equals 42, and then inside I'm going to assign a different value to $var. Now what's going to happen is it's going to create a local copy of var and put 33 in it. The next line, the right host, will display the variable as it exists inside the script block. But to get to the parent, I have to use getVariable, var, and then I pass in -scope, and I use 1 to get the parent variable. So when I run this, you can see that inside the block I get 33. Then for my parent, I get the correct value of 42, and it's still 42 once I get outside the block. Using setVariable, I can actually override the default behavior of creating a local copy, and I can actually assign a new value to it. So here you can see my $var is going to get 42 assigned to it outside the script block. Then once I'm inside, I'm going to use setVariable to assign the value of 33, only I'm going to pass in the -scope so it knows it's the parent version of this I'm talking about. I'm then going to print it out both inside and outside the block. And there we go. I want to stress though that just because you can do this doesn't mean you should. This is generally considered bad practice. What you really should do is, if you want to change the value, is have it returned from the script block and let the consumer of your particular script block figure out how they actually want to use it. When you go changing parent variables like this, it can cause some very undesirable side effects. Now in addition to using get or set variable commandlets with scope, I can also declare something to be of a global or a private scope. With a global scope, I can tell it, I want you to access the same variable no matter where it comes from. So here I'm going to create a global variable of 42, and then within my script block I can access that same value. When I come out of that script block, it will now have changed, and there we go. Outside the block it now has the value 33. I can also create a variable that's private. In a private variable, I can only see it in the current context. I can't even see it within any script blocks I create. So here, when I attempt to write out my unmentionables variable, it's going to not print anything because it's null. Outside the block, however, I can still get to it. I can actually check for this inside the script by looking to see if it's equal to null. It's going to tell you that it can't show you its unmentionables because it's null. Then outside the block, it's got the value of 42. One last thing to note, if you declare a variable inside the block, it's only accessible inside that script block. Once you exit the script block, PowerShell throws that variable away. So here I've created a variable called localBoy, and when I run this, inside the block it retains that value, but once it gets outside the block, it has thrown localBoy away and it's going to be null. We started this video learning how to branch our logic, that is, execute a set of code based upon some condition. Next, we saw how to repeat a block of code a certain number of times. After that, we learned about the power of script blocks. Finally, we learned how variables work inside and outside of script blocks. We covered a lot in this module, but we're just getting started. In the next module, we'll go into the more advanced topics of PowerShell programming, including adding help and creating reusable functions, to name a few of the items. Thanks for watching.